Okay, so yes, welcome everybody. Hannah did a great job of introducing me. I don't have to say much more about myself. So what I'm going to be talking about is ingesting data from a relational database into Cassandra. And particularly, this is for, I guess it's a rare case where you can start afresh in a greenfield situation and you don't have some data elsewhere that needs to be brought over into Cassandra. So that's the use case I'm focusing on, where you have data somewhere else. Excuse me. So kind of two parts. First part, I'm going to talk more about Cassandra, about why this might not be as easy as you would expect. And then in the second part, I'll show you kind of how we can get it all working. So actually, all the credit for what I'm going to show you this evening goes to one of our SEs, Todd McGrath, who used to be a DataStax SE. And this is his slide. I just kind of changed who am I to bouquets to Todd McGrath. So he spent over 20 years in software. He was a DataStax solution architect now at StreamSets. And then all of the mistakes and missteps are mine. So I've been even longer in software. I was at Salesforce, now I'm at StreamSets, and even more different jobs and mistakes and maybe successes as Todd. And if you want to throw rocks at me on Twitter, I'm Metadaddy, and you can ask me afterwards why. Okay, so you're deploying Cassandra in your organization for the first time. Okay, sounds pretty straightforward. Just download it and run. But where are the problems? Where's the long pole here? Cassandra indeed does kick butt. We must all share that opinion, or we wouldn't be here tonight. But it's not your father's database. Data modeling can be tricky. It's very, very different from relational database modeling, which focuses on aspects of the entities that you're managing. Cassandra as an application database, you really start from the queries your application is going to make. So you can end up with a very, very different schema. There's this idea of eventual consistency. What does that even mean? Does that mean milliseconds? It could even mean seconds. It doesn't share a lot of the features of a relational database. It's not ACID. You've got these issues of compaction and so on and so on. Are we going to move on? Maybe my battery died. No? So introducing any new technology into an organization comes with growing pains. As you can tell from my accent, I didn't grow up in the US. I have no idea what this is. I hope somebody in the room is familiar with it. Right. And apparently the guy on the right is Leonardo DiCaprio. Is that right? There you go. In very younger days. So how do you enjoy all these benefits of Cassandra, this huge, massively scalable application database, when you don't have the luxury of rolling it out in a greenfield site? And you've got to refactor an existing application. And can we migrate to Cassandra without burning the ships? Can we do it in a gradual process where we don't literally turn off the relational database and turn on Cassandra at the same time? We want to leave that existing database online and have two systems running simultaneously, and more importantly, have them be consistent with each other. So you can maybe run your existing application, port the data across, build your new application, test them, make sure the outputs are the same, and get all your operations ready for the big switchover. So, what do we need here? There's two aspects to this. The first is getting existing data out of your relational database and into Cassandra. This is actually relatively straightforward, apart from the fact that the schemas could be vastly different. Okay, so it's not just like dump the old database to CSV and read the CSV into Cassandra. There's more to it than that. The tricky bit comes when you want to have both databases live at the same time. And you want to, maybe you're hitting that relational database with the updates, and you want those to be moved into Cassandra. Now, the technology there is called change data capture. This is a pretty standard term in the database industry, and each database has its own mechanism for giving you a stream of changes as they occur, the inserts, updates, deletes, and so on. So what are we accomplishing here? We can move across the historical data, and we need to think about the data model. We need to think about how we translate from that relational schema to Cassandra schema. And we'll see in a moment how different they can be. We want to be thinking about how balanced the data is across your Cassandra nodes, right? Cassandra clustered database. When you load those 10 billion records out of your relational database, you kind of want them spread around evenly. You don't want them landing on one node and have n-1 idle nodes. We want to be able to test both for the replication is working properly, do stress testing, and we want to be able to run analytics on Cassandra in readiness for going live while we keep our relational database up. And then once you've loaded the historical data, you can start streaming the data in. And this really gives you an idea of how Cassandra is going to perform. The updates are going to come from your relational database. Okay, you're still writing data into there. But guess what? The new records are being created, records being modified at real-world rates. So you can see exactly how Cassandra's going to do, even though the data's coming through a pipeline from the relational database and not from maybe your web application or whatever application is going to be ultimately writing to Cassandra. So you can get used to things like compaction, repairs, and you can do things like take a node offline while you're in this cutover period and just see exactly what happens. It's kind of a luxury, really, to be in this state. Because one day, you're going to want to finally switch off that RDBMS system and have Cassandra be the primary, and you want to be pretty damn confident when you do that. So let's look at some options. And this is where, so this is, I have to give Todd credit for this. This is really cool. So if I go, all right, okay, so how do I even get that to go? Right, let's turn the sound off. Right, okay, so Family Feud. Is this going to work now? Show the question. Okay, oh, and I have to get my little bit of prep that I forgot to do. Bear with me 1 second. Here we go, I've got to be the quiz master here with my little index card. Okay, so question 1. What might be an option to one-time bulk load Cassandra from a relational database? So who can give me a guess?
DSC bulk loader.
DSC bulk loader. Well, Cassandra loader I've got on the card. I think that's the closest one. 14. Our survey said 14. Anybody, let's not say StreamSets immediately. I think you're getting ahead of me there. Any other guesses? What you might use? Yeah, Jeff. Spark. Yeah, you could use Spark. You're going to end up writing some custom code there, right? Anybody else? Kafka? You're kind of in the same situation with that. With Kafka, you're going to be writing some integrations. Kafka's a great way to move data around, but you kind of usually need something to integrate the data. Anybody else? Okay, well, did I hear somebody say? Golden Gate? Oh, Golden Gate? It's not on my list. Hang on. Okay, somebody said StreamSets. There we go. So you could have had, using a traditional ETL tool, we all know some of those, and they're extremely expensive. You could have had copy in SQL and Apache NiFi. All right, so let's go to the next question, and thankfully the last. Okay, so once we've got our data into Cassandra, what might be some options to continuously stream changes? So it's kind of a different problem we're dealing with now. So how do we move data on an ongoing basis? And I have to keep putting my glasses on to see the card. Anybody got any guesses apart from the obvious one?
Spark streaming.
Spark streaming, yeah, absolutely. Really popular choice. Again, you're going to have to be doing some work yourself there. You could always, right? How many developers are in the room? You could write some custom code. It's always going to work. It's going to take you time. There's another project there called Debezium. Anybody use Debezium? Heard of it? It's out there. You'll be unsurprised, the number one choice when we ran our survey. Yay! And we love them really, but we like to have a little rag on NiFi there. Right, okay. So let's come out of there and get back to the real slides. Let's have a look at how we get this running. So this is the part where I cross my fingers and hope I'm going to have the working demo of the evening. So here we have StreamSets Data Collector. So what I'm going to do first is show you a little bit about what we've got here. So actually, where's the keynote there? Let's do this bit first. So who's heard of Killer Video? Okay, more of you should have heard it because it's a great Cassandra reference application. Okay, you go to killervideo.com and there's links there to the source code and everything, and it shows you how to build your own YouTube killer in Cassandra. So what we did was looked at what might be a relational database schema if you were going to do this kind of video streaming site. So very standard, pretty small relational schema. We've got movies, users. Users give ratings to movies, so we've got nice foreign key relationships there. And movies can also have be tagged by users. So we've got like a folksonomy there. Now, very familiar relational database kind of schema there with the relations. Now, when we move to Cassandra, it's very, very different. For one thing, Cassandra doesn't have the concept of foreign keys. And for another, what ends up happening is we have pretty much denormalized the data here because we're modeling it according to the access patterns. So we're going to want to get the tags, movie tags by the user. So we've got a table here with the user ID as the primary key and the movie ID in the tag. We want to retrieve the movies from the tag. So actually, this is duplicate data here, but it's following the access pattern from the application for efficiency. So moving between the two becomes a non-trivial exercise. and let's have a look at how we achieve it. So this is, let's make it less of an eye chart. This is the pipeline in StreamSets. So we've built this pipeline, and it's actually going to be easier if I just run it first, and you can see it in operation, and then we can step around it a little bit. So what I've got kind of in the background is MySQL, and I've got, for the purpose of having a demo that shows in a reasonable amount of time on my laptop, I've got 1,000 movies here in MySQL, all with very realistic descriptions. And what I'm going to, and I've got movies, ratings, tags, and users. And what I can do is I can move those across by running this pipeline. So what I should be able to do is click Start. Now this takes a few seconds to start up because it's got to connect to MySQL, it's got to hook up all of these database connections here, and it's got to connect to Cassandra. So this is the moment when I know it takes a few seconds to start, but it always takes a second or two longer than I'm comfortable with taking. So let's will it into working. There. Oh, okay. Oh, I know what I've done. Okay, so rule 1, always reset the pipeline because it remembers how much data it processed. Okay, so let's do that again. It'll be faster this time. So what happened there was the pipeline, by default, keeps track of how much data it's processed and won't reprocess the data. So obviously I was playing with this earlier, and I didn't reset the pipeline to say, okay, start again from the beginning of the data. What we should see here now is when it gets started, it'll process 2,000 records, in fact. So 1,700, 2,000, and then it'll stop. And you'll see here that the output here is many more records than the input, because as those two schemas implied, we have many more records in Cassandra. What it's done is it's broken out those records. And if I go over to Cassandra in the shell, what I can see is, where are we? This one. So I just did it before when I was sitting there. I said select star from movies just to check. So if I do select star from movies, limit 10, we should have a whole bunch of movies moved across. So how do we do that? How does this work? Well, I'm reading multiple tables out of MySQL. Okay, I've got this multi-table consumer, and I've configured that with a connection string. So this is just a parameter I've pre-configured. And down, where is it, tables. I've said, okay, I'm going to use a killer movies schema, and I want the users table and the movies table. Okay, because that's where our data starts in that schema. Those are the kind of the root of the data hierarchy. Now you'll notice here, I'm going to stop the pipeline when I have read all of the data. By default, these pipelines will run forever. But in this case, I'm doing a one-time load. So I say, okay, stop pipeline when there's no more data. Can everybody see the words? And then, okay, so once I read the data in, I add some metadata. So I'm setting some operational things there, created at. Operation type is 1. That's what I'm using for creating records in Cassandra. And now I can convert some fields, so the operation type wants to be integer. And then I can switch the data according to whether they're movie or user records. So for the movies, I look up a UUID. Okay, I've got my mapping from sequential keys in MySQL into UUIDs that Cassandra would like. And I'm going to insert the movie into the table. So that's really straightforward. I read in every movie and create a Cassandra record for every movie. Now for the users, I look up the UUID, and then I look up all the ratings and the tags that that user created, as well as inserting the user record. So I'm actually splitting the data 3 ways here, and it's going to do all of these three. It's going to do all of these 3 operations. So if there's any ratings, it'll insert into the movie ratings by user, and so on. It'll insert into movies by tag. So we're populating all 1, 2, 3, 4, 5 Cassandra tables in this single pipeline. So it's pretty efficient in the way that we can do the whole job in one pipeline here. Okay, so we've got some data. What happens now? Well, let's see. We loaded the data. We changed those primary keys to UUID, so we just have like an operational table to map between the two. Now, we could generate UUIDs on the fly as we're writing them into Cassandra, but that would make it much more complex because when we're processing those users, we're writing to multiple tables. Having a mapping pre-configured makes things a bit easier there when we're writing to a bunch of different tables. We know that all of the mappings from a MySQL record ID to a UUID are already configured. It was a batch job, so we stopped when it completed. And really, we have almost like configuration as code. We can export this pipeline as JSON and keep it under change control if we want to. One thing I didn't do when I was looking there, when we're getting this kind of stuff ready, we can do a preview. So as I'm building my pipeline, let's take a few seconds again. As I'm building my pipeline, I'm configuring all of these processing stages. I'm setting up expressions here to say which way the records should be sent, and so on. I want to have a bit of confidence in what's happening. So this is the first 10 records from the database. So if we just make them big. So record 1, record 2, so on. So what we did was we just read the first 10 records, and then we can follow it around the pipeline. Now what's really nice here, hang on, let me just refresh it. Oh. Okay, ignore there's some glitch in the UI, this output box. What's really nice here is I see that this add metadata stage added 2 fields. I see that this was converted from a long to an integer. And I see here that these are all sent along stream 1, okay, because they all come from the movies table. And then I can see the lookup to get that UUID. And I can kind of follow this round. Okay, there wasn't one there because this is a movie. But I can see the data that gets as far as Cassandra, but it didn't write it because this is just a preview. So really nice observability. Okay, so we can be pretty sure that what goes into Cassandra is what we intend. And we can also do things like snapshots. So as the pipeline's running on a longer job, we can jump in and scoop out some data and do that same examination. So now we come to the really cool bit. That was a batch pipeline that runs and then stops. Let's have a streaming pipeline that runs continuously. So we have an origin for MySQL that uses their bin log, like basically reads their transaction log. And we have many others. We have Oracle, MongoDB, Salesforce, Postgres, etc. And it's important here to consider what's happening. We often want to retain a history of operations versus map those operations directly. So if you can imagine, if something's updated in MySQL, we might not want to mutate the row in Cassandra. We might want to write a new row so we have a history of changes. Similarly, when we delete something, we might just set a flag on it so it's not deleted from Cassandra, so we have the history. So there's a lot of flexibility you can get when you're building these pipelines. So yeah, let's look at the change data capture. So pretty similar, but a little bit different. And what I'll do again is I'll just set it going. Now this is, once it says, goes from starting to running. So this is going to monitor MySQL. So it's monitoring that MySQL transaction log. And then for every change, it's going to basically go down this sequence of operations. So set the table name. Okay, something's been weird. Okay. Okay, bear with me a second here. Okay, I'm gonna restart this while. I'm actually using the master copy out of GitHub. So I run on the bleeding edge, I don't run the release. So what I'm doing is I'm just restarting StreamSets. So what's going to happen is we're going to go along this sequence of operations and basically map this transaction data into changes that we can apply to Cassandra. So I guess it's the night for demo gremlins. So this is going to start listening now, come on. Takes a few seconds. I've got every single connector under the sun loaded into this thing, so it's got to load jar files and so on, so on. Come on. Okay, any questions about what you've seen so far while this gets going? Okay, all clear? Right. Ah, there we go. Right, so if we go super secret password, CDC, it's starting. So it remembered the state it was in. It was trying to start. So it tries to start again. Come on, come on. You can do it. Let's go. So while that starts, let's go over to Cassandra and say, get a bunch of the movies based on a tag. So Cassandra. Okay, so these are 10 movies with a particular tag. And they've all got movie IDs. Let's see, select star from movies where, hang on, just do select star from movies, limit 10. What I'm after is getting just one movie that we can pick on. Here we go, actress, the Dollars and the Transylvanians. Okay, so that will be that ID. So what we want to do is focus in on a single movie because we're going to change it. Select star from movies where ID equals that. Okay. And I didn't know about this expand on thing until I saw this. So, okay, so there's our description and name. Oh, I know what I've done. I've been dumb again. So, in common with last time, I forgot to reset the origin. So it was looking for changes that no longer existed because I'd truncated tables and all sorts of great stuff. So forgive me. I thought I'd reset the demos, but they bit me. Okay, so this time it'll start. Okay, so what we're going to do is we're going to change this actress, the Dollars and the Transylvanians. So let's go find it. So actress, there we go, actress, the Dollars and the Transylvanians. I've never seen that movie. Running, okay, so what we're going to do is we're going to change this to the description to Cassandra is awesome. And what we should see is a record flow across here. Oh, okay. We, of course, have to commit the change. Then we see the record fly across there. I have done this before, folks. And then if we do exactly the same select, then we see that the description has updated to Cassandra is awesome. So once you deploy it into production, it's much less torturous than showing it on stage, I promise. Okay, so we saw the continuous approach there, and also the fact here, so this is pretty important to see here. If you see this select, I've actually got 2 records. So I've kept the old one with the time, and 1 was an insert, 3 was an update. So here in my model, I've elected to keep that history, and I'm able to do that in the pipeline there. All righty. Oops. So hopefully in between the glitches, you got an idea there of what was going on. So, yeah, happy to take questions. Yeah.
How are the failures handled in your StreamSets pipeline?
That's a great question. So the question was, how are failures handled? So there are 2 types of failures. There are record failures, where maybe the data within a record fails some validation, maybe the data type of a particular field is incorrect. And then there are pipeline failures where maybe the destination's gone offline. Okay, so record failures, each pipeline has the concept of an error stream. So say we're processing a stream of records, 99% of them are processed correctly, the remainder have some kind of error. They're written to a separate stream. So that could be into a file on disk, or a Kafka topic, or wherever you like. And then they can be reprocessed, examined, whatever, maybe remediated manually and sent back through the pipeline, whatever you like. And within those error records is the original source data and the whatever, error metadata, whatever error it triggered in the pipeline. So those are like transient record level errors. Now, you can also have pipeline failure for many, many reasons. Now, what happens there is as data collector is reading the origin, it's keeping track of how far through it is. So if you imagine in a relational database, that might be record ID or last updated time, or with a Kafka topic, if we're reading from Kafka, it would be like the Kafka offset. Now, as it's processing records, the only thing that StreamSets saves of the data is the last offset that it processed. So if the pipeline halts, when it restarts, it's got that pointer into where it was. Now, it's a little bit like Spark. Data Collector's a microbatch architecture, so it will grab, say, 1,000 or however many you configure records at a time. And if you fail halfway through, the offset is the beginning of that batch. So it can rewind to the beginning of that batch and then restart and reprocess. Yeah.
How do you scale a pipeline?
How do you scale a pipeline? Another great question. So you can run, the easy answer is it depends. It largely depends on the data source, okay? Your ability to partition the data source.
Let's say it's partition.
Yeah. Right, so say, so the classic use case is Kafka. Okay, Kafka topics can have n partitions. So you can run n copies of the pipeline each on a different machine. And basically Kafka does the hard work of partitioning there. They're all in the same consumer group, and they'll all receive records from a different partition of their Kafka topic. But it varies wildly. Kafka's super easy because it does the partitioning for you. In the case of, say, reading from a relational database, We might we have multi-threading within that origin to read tables simultaneously, or you might decide to have pipelines on different machines reading different tables. It starts to get complicated where the origin can't be naturally partitioned like that.
But does it scale internally? Let's say if pipeline kind of, let's say we have a Kafka topic with thousands of partitions,
Mm-hmm.
and definitely cannot handle by single instance of pipeline.
Yeah, so
Kind of, do you have a cluster of machines?
so you can go either vertically or horizontally. So the Kafka origin is itself multi-threaded, and so you can run multiple threads within one instance of data collector, and you can have data collector running on multiple machines. So, you know, whichever way you want to do it, you can scale to the you could scale to the available hardware and across the Kafka partitions. Does that answer the question?
A little bit, but that means I have to deploy data collectors, right? And I cannot deploy through UI because I thought once you put this kind of arrows
Mm-hmm.
on the topic
Mm-hmm.
through the pipeline into destination, it will automatically kind of scale based on the value of the output.
So I showed you. Okay, so I haven't got to the slide that tells you about a little bit more about this. I showed you the pipeline design environment and engine, which is Apache 2 licensed open source. We have a management layer called StreamSets Control Hub, which will basically, you can define the level of parallelism, and when you start a job, it runs n pipeline instances simultaneously on different, so you have the data, you can have your cluster of data collector instances running, okay, waiting for work to do, and you press go in the control hub, and it sends the pipeline to n different data collector instances, and it starts it running in parallel. And you can even set it up with Kubernetes, so it'll basically, you don't even have to pre-install data collector instances. It'll just say, give me however many pods. Yeah.
Based on what you said, can you do an in-flight throttling? Like, is that possible?
Sorry, an in-flight?
Like, I have a streaming going on, and I see that, you're impacting my workload that is happening on my Oracle database. Let's say that,
Mm-hmm.
you're many number of threads. Now I want to reduce it. I want to make sure that you're not impacting the live traffic that is coming in. I want to throttle the.
You want to throttle it? Yeah. So in the origin, I can say, let's see, where's a good one?
My question is, can it be done on the fly?
On the fly? No, but I can stop. But don't forget, the pipeline has an offset into the data, so I can stop it, and I can change some of the configuration, like queries per second here, and then restart it. And it won't lose any data, right? Because it knows where it is. You stop it, restart it, and it'll just start from where it finished reading.
So break and then you start it.
Right, right.
A follow-up question on that.
Yeah.
I have a huge amount of data that I need to stream, right?
Mm-hmm.
And I also heard that it reads the logs, right? It reads the active logs or the archive logs that are there on the
Yeah.
source, right?
Yep.
So does it take care, as soon as I start the process, does it take care of that snapshot, and does it know where it has to start reading the logs, or it starts reading the logs as soon as I start the process?
It's the latter. So yeah, you have to manage that cutover from reading the existing data and starting reading. But you can set the point at which it starts reading. So I know in the Oracle CDC origin, you get to set the starting SCN. So you can start it exactly where you want in the history. But yeah,
Or else I need to manage my logs to make sure that the migration is fully complete.
yeah. So change data capture is not an introductory feature. So there's quite a lot to think about in how long you retain your logs. And there's lots of levers and switches to set to balance performance on the data collector machine versus impact on the Oracle database. So you can do you can shift the workload between the two.
So what I was trying to ask is, can I not start my work? I have my table data, as well as I have my logs that are constantly getting generated. Can I do both the things in parallel? Saying that can I start streaming the data from my tables as well as from the logs?
Right. Yes. Yeah, so what you do then is you would pick a point in time, like within the log history, and you would say, okay, I want to read data in my bulk load, I want to read data that's older than that, and in my live streaming pipeline, I want to read data from that point onwards. So yes, yeah. You'd need to figure out like the key, exactly how you define that line. But yeah, there's no reason you couldn't do that. All right, so just hop back. I think I've just got a couple more slides to round things out. So as I mentioned, it's Apache 2 license open source, as well as, so I mentioned Oracle, I mentioned MySQL. We can read Kafka, flat files, JMS queues, you name it. We can tail files, we can read files from directory. And as well as Cassandra, we can write to Hadoop, MongoDB, files again, HTTP destinations. I think there's around about 40 or 50 different connectors in there. All sorts of fun. And this is all actually in the DataStax Academy. So if you Google Cassandra StreamSets, this will probably be in the top 5 results, academy.datastax.com. So Todd actually wrote that up. Or just send me an email, and I can send you links to resources and all kinds of fun. And you don't even have to copy my email down because I've got my cards here. So with that, any more questions? Okay, I guess we'll wrap up then. Thank you very much.